kind of in the middle of this, but we're in the trig part. Triangles, right triangles. So if you go from short leg to long leg, you multiply by root 3. If you go from long leg to short leg, obviously you divide by root 3. If you go from here to here, you multiply by 2. And if you go from here to here, you divide by 2. That's what all that jazz is saying. Now, what makes it so beautiful that you can remember this, if this is an equilateral triangle, which is also equiangular, if this is 1, what is the length of this going to be? 1/2. Because didn't this get divided by 2? So this would be 1/2 right here. If this is 1, this would be 1/2. If this was 2, this would be 1. You always, if you know the hypotenuse, you have to find the short leg before you find the right triangle, or before you find the long leg. If you know the long leg, you have to find the short leg, and then you can find the hypotenuse. You always have to go through the short leg, and that's our reference leg. So let's look at this whole thing. If this is 13, what will this be on number 4? If this is 45, this is 45 because this is 90. X is what, Alex? 13 root 2. You're just going to multiply by root 2. Okay, Abraham, if this is my hypotenuse, how am I going to find the leg? Think it's 45, 45, 90.
Hypotenuse over root 2.
Very good. So it's 9 radical 2, divide by radical 2. So this is 9. Okay, try this one now. Andrea, what would you have to do on 6?
Go to the leg of the hypotenuse. You would do 28 equals root 2x. And then
Okay, so you can just automatically do it. What are you going to do to go from the leg to the hypotenuse? You multiply by root 2. So now what would we do to undo it if you know the hypotenuse and you want to go to the... You divide by root 2. Okay, very good. We had this a way back. Can I leave it with a radical in the denominator? No, so I rationalize it. So you get 28 root 2 all over 2, and that would reduce to 14 root 2. Okay? Because this reduces. Okay, Alexander, what would I do to find the hypotenuse here? Very good. You're going to multiply it by radical 2. And what's radical 2 times radical 2? 2. And what's 2 times 7? Very good. So you have 14. Are we all good? That's what the 45, 45, 90. Now let's practice the 30, 60, 90. Okay, on here, so once again, they're still doing the same thing. Okay, what would we just do on this one? Karen, what would I do on number 8? 9 divided by root 2, and then I'd have to what? Rationalize. So you multiply by root 2 over root 2. You get 9 root 2 over 2. Can I reduce those 2's? No, because one's irrational, one's rational. You are done. Okay, on here, see, here's my square. This is the hypotenuse. How would I find, Anna, the leg?
X equals 24.
24 what?
X equals 24.
Okay, 24 over radical 2. Can I leave it like that?
No.
So what would I do now?
Multiply the numerator and denominator.
Okay, so you're dividing because you're going from a longer to a shorter side. So you're dividing it. It kind of makes sense for you to remember that. So you would get 12 radical 2. So now we're finally to a 30, 60, 90. Notice on these, all you need to know is one side, and I can find out x and y. This radical 3, is this the short leg or the long leg? Why is it the short leg? Because it's opposite the 30-degree angle. So if this is a short leg, M, what would be the long leg? You multiply by what? 1/2. When you go from short leg to long leg, you multiply by √3. And so this would just be 3. This is the long leg. Now, to go to the hypotenuse, remember everything comes from the short leg. What am I going to have to do to the short leg? Multiply by 2. Think of my little triangle. Remember, this is the hypotenuse. It's going to be twice as long as this. So I'm going to multiply this by 2. So this would be 2√3. Okay, you guys try and do this one. You're welcome, sweetie. Okay. Obtain, which one's the short leg? Okay, this is the hypotenuse, so I have to find the short leg first, and what would that be? Nine. It's half of it. I just showed you. This is the short leg, this is the hypotenuse. Look at where it's coming from. The short leg is half of this. You broke it into 2 equal parts here. Doesn't that make sense? So the short leg is half the hypotenuse? Okay, so if this is 9, then what's this? 9√3. You multiply this by √3. Okay? Short leg to long leg. You multiply by √3. Short leg to hypotenuse. You multiply by 2. If you have the long leg, you got to find the short leg. You're going to divide by √3. If you have the hypotenuse to the short leg, you divide by, √3. You divide by 2. Okay, and then if you want to go on and find the hypotenuse, you would be multiplying by 2 from the short leg. Everything has to get to the short leg, and then you can find the other thing. Okay? Now, down here, let's just worry about these right now, sine, cosine, and tangent. Have you heard of sine opposite over hypotenuse? Please say yes. This is so. Ka. Did you ever hear that? Toa. So this is sine, which is opposite over hypotenuse. This is our 3 primary trig ratios. We'll study these later, but right now, let's look at this. So if I talk about the sine of A, the opposite angle would be, class, what? M over the hypotenuse, P. The cosine would be what, Borna? The cosine would be what? Do you know? It's adjacent. That means the side that's adjacent to angle A, not the hypotenuse. So it has to be N over P. Okay? Did you have this in geometry?
No,
You skipped it? No, did you? Did you skip it? No. I would think that this is... Okay, tangent, opposite. Will, what's your opposite? M over N. This is your adjacent. This is your opposite. This is your hypotenuse. So now if I'm talking about sine C, here's my right angle. Which one is the hypotenuse on this? Y. What is the adjacent side? W to C. This would be the adjacent. It's what forms that angle. Okay, so then what would, and this is the opposite. So what is the sine of C? Good. Matt, sir, what would be the cosine? Sir. What would be the cosine? W over Y. Good. And Jonathan, what's the the tangent? X over W. Are we good on this? Or a little shaky? You guys fill these in. Just go really. Okay, first of all, how am I going to find this third side? Let's just do this once. This. Pythagorean theorem. When you know 2 out of the 3 sides, you can use the Pythagorean theorem. So you have 64 plus 225 equals C squared. So you have 289 equals C squared. So that is 17. Okay, so just do these 2 rows. Notice this is angle B, because we have to have this for our trig chapter. No decimals, it always is left as a ratio. Ashley, what'd you get for sine of B? I'm sorry, what? Thank you, Max. Okay, this is, in this case, this is your opposite. That would be your adjacent, because it's adjacent to B. This is your hypotenuse. The hypotenuse always remains the same. It depends on what angle. Here, this is the adjacent for B. This is the adjacent for angle A. Okay, so have that straight. James, what did you get for cosine of B?
8 over 17.
I'm sorry, what?
8 over 17.
8 over 17, you are correct. And then Pooja, tangent? 15 over 8. Good. Okay, now we're talking about the sine of A. So this is my adjacent, this is my opposite. Josephine, what'd you get for sine of A? 8 over 17. Good. Sikander, cosine? 15 over 17. And the last one, class, would be? Okay. Any questions on that? Okay, good. Now go back to the first page. There's not much there. Okay, periodic data. Okay, a periodic function repeats a pattern of y values, outputs of regular intervals. A cycle is one complete pattern. A period is the horizontal length of it, and you'll see. An amplitude is half the difference between the maximum and minimum values of the function. So now just turn the page and we're going to just do a couple of these. First of all, a periodic function repeats the pattern. So do you think number 1 is a periodic function? No, because it doesn't keep, you're exactly right. How about number 2? Yes, and if I would want to find its period, it's the horizontal length. So it's, if I start at 0, where does it start repeating again? It goes up and down, and then here it starts again. So this is its period. The period is 2. Okay? On this one, do you think this is a periodic function? Yes, and what would be its period? 4. How did you get 4? If it starts at 0, I would not say 4, because look at where it is here. This is where it starts repeating again. Starts going off. So what would that length be here? A little bit over 3. We'd be guessing around 3.2. So don't just look where it intersects the x-axis, which I think you were, Max. Okay, now on here, these are functions. So if you look at this, if we want to find the period, let's say of this one, Max, what do you think the period of number 4 is? What is the period? If you start here, where does it start repeating? What is the length from here to here? 3 point. Okay, good. Now, how do you identify the period in 2 different ways? I think this is kind of silly, but this is what we do. We go like from, we could say one of them is from 0 to 3.1, what he just said. Another one could be from negative 3.2 to 0. Oh, I should keep it the same. 3.1 to 0. So the length is always the same. Okay, that is how you're just identifying the cycle 2 different ways. Here's one from 0 to 3.1. Here it is also. From here to here, which is around negative 3.1 to 0. So let's look at one that's a little bit cleaner. How about here? What is the period? The length of the period is what, class? 4. It goes above and below. You have to find out where it starts above again. That is a whole cycle, right? And then it starts repeating. Now, how could I identify it? I could identify it from negative 4 to 0. I could go from 0 to 4. I could even say negative 2 to 2, if you wanted to look at it that way. Then that's another cycle. It went below and then up. Here I did the up and then below. So many different ways. So do you understand what a cycle is? The last thing is the amplitude. The amplitude is half the height or half the distance from the maximum point to the minimum point. So here my maximum point is 1. My minimum point is negative 1. The distance is 2, so it's 1/2 times 2. So the amplitude is 1. Does that make sense? If you look at this one, what would be the amplitude of number 8? Any ideas? What's the maximum is? 3. The minimum is? -1. What's the distance there? 4. So half the distance of 4 is 2. That is the amplitude. What's the period? When does it start repeating? Here I start. If I start at 0, it's going to go to there, right? My period is from this point to this point. What is the length of that? 3. You could have chosen from here to here also, 3 to 6, if that makes more sense to you. Still, what is the horizontal length? The horizontal length, the period is 3. The amplitude is how high it goes, from the maximum to the maximum to minimum, and half the distance. So if you would just kind of put a little, let's say, here, like right through the middle, this is 2 above and 2 below. And that's what my amplitude is. Let's do one last one, number 9. What's the amplitude of this? Watch the scaling. What's the highest point here? 2. And what's this? -4. So what's that distance? 6, right? And what's half of 6? Half of 6 is 3. So the amplitude is 3. What's the length of the period? 4? 2. Here's where it starts repeating, right here. Here it starts repeating. So this is my period from here to here. This length, the period, is 2. Okay? Does that make sense? Okay, that's it. Yay!